So it looks like it's doing something like that, maybe something like this, right? And it's going in this direction. Yeah? So now let's take a look at finding the equation of the tangent line at t equals 2. Okay? At t equals 2, the equation of the tangent line, the slope, is still, this is still my x-axis and this is still my y-axis. So my slope is still dy dx. Right? So my slope is still dy dx, but I have x in terms of t currently, and I have y in terms of t. So I don't want to find the derivative of x, derivative of y, with respect to x necessarily. I really want, what I can find is I can find dx dt and dy dt. So I can find the derivative of x with respect to t, and I can find the derivative of y with respect to t easily. So this becomes, the derivative of x with respect to t becomes 4t cubed minus 6t. The derivative of y just becomes 1. Now, what does this mean? Let's take a look at what this means first of all. First of all, this means that my y is pushing in the positive, is always 1. My change in y with respect to time is always 1. So at any given point in time here, at all of these points, my y value is always pushing up at 1. All of it, everywhere, everywhere, everywhere. My x, however, is changing. My x of t, let's find out when x of t is 0. When I find x of t, I'm seeing x prime of t. So when dx dt, when does that equal to 0? I'm going to factor out the 2t. I'm left with 2t squared minus 3. So at t equals 0 and plus or minus square root of 3 over 2. Now what this means is here at t equals 0, negative square root of 3 over 2, positive square root of 3 over 2. My x happens to be pushing in different directions. The change of x is changing differently. So at x equals, let's see, it looks like x equals, was moving in this direction. So this is all positive. X was pushing, pushing in the negative direction. From here, it looks like x is now moving in this direction, so the positive direction. After this point is when it's, again, it's going this direction. So all the way up until here, which is what I'm assuming is negative 3 square root of 3 over 2, x is pushing this way. And here, towards the negative x. And then from here to here, it's pushing towards the positive x. Now, if you didn't understand that, that's where my Etch-a-Sketch comes in so nice and handy. This means my y is changing with the positive 1, with the speed of positive 1, you could say, or is it changing at a rate of 1? X is changing at this, it switches from negative to positive to negative to positive. So that means if you have yourself your Etch-a-Sketch, this, oh no, you can't see it. Here we go. This y, this is my y of t, so that moves up and down. This is my x of t, so that moves side to side. This means right here that y is constantly pushing up at the same value of 1. And while this is constantly moving up, this one is going to be changing from negative to positive to negative to positive. So let's take a look if I can do this. Let's move this back down here. It'll look like, can you see it here? So this is moving up. My y is always going to be moving up. My x is going to move from left to right to left to right. So moving up, so left So it's going too fast, to right, to left, to right. So something like that is what you can see it looking like if I did a perfect job. So that's kind of how that works. The dx dt, dy dt, change of x and change of t, change of y is what that tells you. However, when we talk about the slope is still dy dx, which means we don't want the t in there. So in this case, the dy dx would be the same thing as dy dt. Do you see how those will cancel? Over dx dt. Because then these dt's will cancel, and you'll be left with dy dx. So right here, dy dx is 1, and dx dt is 4t cubed minus 6t. And then you can find that at t equals 2, which is what the question was. Find this at t equals 2.